A small wind turbine is a wind turbine used for microgeneration, as opposed to large commercial wind turbines, such as those found in wind farms, with greater individual power output. These turbines may be as small as a 50-watt generator for boat, caravan, or miniature refrigeration unit. Design. Smaller scale turbines for residential scale use are available. They are usually approximately 7 to 25 feet in diameter and produce electricity at a rate of 300 to 10,000 watts at their tested wind speed. Some units have been designed to be very lightweight in their construction, for example 16 kilograms, allowing sensitivity to minor wind movements and a rapid response to wind gusts typically found in urban settings, and easy mounting much like a television antenna. It is claimed, and a few are certified, as being inaudible even a few feet under the turbine. The majority of small wind turbines are traditional horizontal axis wind turbines, but vertical axis wind turbines are a growing type of wind turbine in the small wind market. Makers of vertical axis wind turbines such as WePower, Urban Green Energy, Helix Wind, and Windspire Energy, have reported increasing sales over the previous years. The generators for small wind turbines usually are three-phase alternating current generators, and the trend is to use the induction type. They are options for direct current output for battery charging and power inverters to convert the power back to AC, but at constant frequency for grid connectivity. Some models utilize single-phase generators. Some small wind turbines can be designed to work at low wind speeds. Dynamic braking regulates the speed by dumping excess energy, so that the turbine continues to produce electricity even in high winds. The dynamic braking resistor may be installed inside the building to provide heat. The location makes low-voltage distribution practical. Small units often have direct drive generators, direct current output, lifetime bearings, and use a vane to point into the wind. Larger, more costly turbines generally have geared power trains, alternating current output, and are actively pointed into the wind. Direct drive generators are also used on some large wind turbines. Installation: turbines are often mounted on a tower to raise them above any nearby obstacles. One rule of thumb is that turbines should be at least 30 feet higher than anything within 500 feet. Better locations for wind turbines are far away from large upwind obstacles. Measurements made in a boundary layer wind tunnel have indicated that significant detrimental effects associated with nearby obstacles can extend up to 80 times the obstacle's height downwind. However, this is an extreme case. Another approach to siting a small turbine is to use a shelter model to predict how nearby obstacles will affect local wind conditions. Models of this type are general and can be applied to any site. They are often developed based on actual wind measurements, and can estimate flow properties such as mean wind speed and turbulence levels at a potential turbine location, taking into account the size, shape, and distance to any nearby obstacles. A small wind turbine can be installed on a roof. Installation issues then include the strength of the roof, vibration, and the turbulence caused by the roof ledge. Small-scale rooftop turbines suffer from turbulence and rarely generate significant amounts of power, especially in towns and cities. Markets. Japan. In July 2012, a new feed-in tariff approved by Japanese Industry Minister Yukio Edano went into effect, promising to boost the country's production of wind and solar energy production. The country is aiming to increase renewable energy investment in part as a response to the Fukushima radiation crisis in March 2011. The feed-in tariff applies to solar panels and small wind turbines and requires utilities to buy back electricity generated from renewable energy sources at government-established rates. Small-scale wind power will be subsidized at least 57.75 Japanese yen. United Kingdom. Properties in rural or suburban parts of the UK can opt for a wind turbine with inverter to supplement local grid power. The UK's microgeneration certification scheme provides feed-in tariffs to owners of qualified small wind turbines. United States. Small wind turbines added a total of 17.3 MW of generating capacity throughout the United States in 2008, according to the American Wind Energy Association. That growth equaled a 78% increase in the domestic market for small wind turbines, which are defined as wind turbines with capacities of 100 kilowatts or less. AWEA's 2009 Small Wind Global Market Study, published in late 2009 May, credited the increase in part to greater manufacturing volumes, as the industry was able to attract enough private investment to finance manufacturing plant expansions. It also credited rising electricity prices and greater public awareness of wind technologies for an increase in residential sale. But a poll of small wind manufacturers found that the growth in 2008 might be only a glimmer of things to come, as the companies projected a 30-fold growth in the U.S. small wind market within as little as 5 years, despite the global recession. The U.S. small wind industry also benefits from the global market, as it controls about half of the global market share. U.S. manufacturers garnered $77 million of the $156 million that was spent throughout the world on small wind turbine installations. A total of 38.7 MW of small wind power capacity was installed globally in 2008. In the United States, residential wind turbines with outputs of 2 euro 10 kilowatts typically cost between $12,000 and $55,000 installed, although there are incentives and rebates available in 19 states that can reduce the purchase price for homeowners by up to 50%, to $3 per watt. The U.S. manufacturer Southwest Wind Power estimates a turbine to pay for itself in energy savings in 5 to 12 years. The dominant models on the market, especially in the United States, are horizontal axis wind turbines. To enable consumers to make an informed decision when purchasing a small wind turbine, a method for consumer labeling has been developed by IEA Wind Task 27 in collaboration with IECTC 88MT2. In 2011 IEA Wind published a recommended practice, which describes the tests and procedures required to apply the label. Croatia Croatia is an ideal market for small wind turbines due to Mediterranean climate and numerous islands with no access to the electric grid. In winter months when there is less sun, but more wind, small wind turbines are a great addition to isolated renewable energy sites. That way solar and wind power provide consistent energy throughout the year. Germany In Germany the feed-in tariff for small wind turbines has always been the same as for large turbines. This is the main reason why the small wind turbine sector in Germany developed slowly. In contrast, small photovoltaic systems in Germany benefited from a high feed-in tariff, at times above 50 € per kilowatt-hour. In August 2014 the German renewable energy law was adjusted, also affecting the feed-in tariffs for wind turbines. For the operation of a small wind turbine with a capacity below 50 kW the tariff amounts to 8.5 € for a period of 20 years. Due to the low feed-in tariff and high electricity prices in Germany, the economic operation of a small wind turbine depends on a large self-consumption rate of the electricity produced by the small wind turbine. Private households pay on average 28 cents per kilowatt-hour for electricity. As part of the German Renewable Energy Law 2014 a fee on self-consumed electricity was introduced in August 2014. The regulation does not apply to small power plants with a capacity below 10 kW. With an amount of 1.87 € the fee is low. DIY construction Some hobbyists have built wind turbines from kits, sourced components, or from scratch. DIY wind turbines are usually smaller turbines of approximately 1 kilowatt or less. These small wind turbines are usually tilt-up or fixed/guide towers. Do-it-yourself or DIY wind turbine construction has been made popular by magazines such as Other Power and Home Power. Organizations as Practical Action have designed DIY wind turbines that can be easily built by communities in developing nations and are supplying concrete documents on how to do so. See also, WWEA World Wind Energy Association, DonQI Independent Energy, Open Source Hardware, Zytec Group, Wind Turbine Design. References. Further reading, Dan Fink. Dan Barkman. Homebrew Wind Power. Bookville Publications LLC. ISBN 0-9819201-0-1. External links, information about small wind market by WWEA, bladeless wind turbine, a Dutch government test of 10 wind turbines, challenges of introducing reliable small wind turbines, fact sheet from the American Wind Energy Association, OFPA, a group of alternative energy enthusiasts, an example of DIY small wind turbine.